So in this session, we will continue with the discussion that we are doing for the last 3 sessions, right? So if you remember, we have had completed 3 sessions, right, on coordinate geometry. So we'll continue the same. So if you go for a quick recap of what all things we have discussed, we started off with distance formula and we understood and we have solved the questions also. Then we moved on to section formula. Then we have seen midpoint formula and we have seen some questions, right? Then after that, we have discussed about area of triangle. Then for that matter, we have in fact discussed about area of any polygon, if you remember, by using the ladder method. So if any polygon with n sides and n vertices are given, you know how to find the area. Then we have discussed about the concept of collinearity, right? And we have solved one question related to that also. After that, we moved on to discussing about the centers of triangle, and we have seen 5 different types of centers. First one being centroid, then we have discussed about incenter, then we discussed about excenter, then orthocenter, then circumcenter. So we understood these 5 centers. So what was centroid? Centroid is actually the intersection of median. Okay. Then what is incenter? Incenter is the intersection of angle bisectors, internal angle bisectors. Now why I am discussing internal angle bisectors specifically, because when we discuss about excenter, we need to talk about external angle bisector. So what was external excenter? It is the intersection of one internal angle bisector and 2 external angle bisector. So if I ask you what is the excenter opposite to A, then you need to drop the internal angle bisectors from the vertex A and external angle bisectors from B and C. Same is the case with excenter opposite to B and excenter opposite to C. Okay, we have already understood that. Then what was orthocenter? Orthocenter is the intersection of altitudes. Okay, so you may have confusion between orthocenter and centroid. What is the difference? See, both are coming from vertex. Okay, so see, if you remember, in case of centroid, we were talking about median. In orthocenter, we are talking about altitude. What is the difference? Median is a line segment which is joining the vertex and the midpoint of the opposite side. Okay, so midpoint of the opposite side, that is not necessarily perpendicular, that is just joining the midpoint. When we talk of altitude, it is again the line segment which is coming from the vertex, but it is perpendicular, it is touching the opposite side and making perpendicular, but it is not necessarily the midpoint. Okay, that is the difference. In the first case, it is not perpendicular, but it is a midpoint. In the second case, it is not necessarily midpoint, but it is perpendicular, but both are coming from vertex. And the last one we have seen is the circumcenter. What was that? When you take the perpendicular bisectors from each side, the intersection of perpendicular bisectors. So how is it different from median and altitude? Here you are dividing equally the other side, the side you are dividing equally. That means it is bisector. At the same time, it is perpendicular. So dividing equally and perpendicular, but it is not touching the vertex. Okay. So we completely understood all those things and I have shown you everything in the diagram. So that's why I'm not writing or drawing anything over here. So we are just going for a quick recap, right? Now corresponding to incenter, we have seen in circle and in radius. Corresponding to excenter, we have seen x circle and x radius. And corresponding to circumcenter, we have seen circle and circumradius. So this is what the discussion we have done so far. In this session, so this is our 4th session, we are going to talk of straight lines. Okay, very, very important topic. Okay, so what is straight line, or what is the general equation of a straight line? See, if you take any first degree equation on x and y, that represents a straight line. So what I'm saying is, any first degree equation in x and y will give you straight line. So to be more specific, the general equation of a straight line is given as ax plus by plus c equal to 0. So this is the general equation of a straight line where a, b, c are constants. Okay, so a, b, c are constants. Now if you take this straight line in my Euclidean plane, if I take this straight line, okay, so this is line L. So if line L is represented by this equation ax plus by plus c equal to 0, if I take any point on this particular line, let me take this point P, which is so when I take a point in my Euclidean plane, I'll have to express that point in terms of 2 coordinates x and y, right? So I will have x1 and y1. So if this line is represented by this equation, any point on this line, if you take and if you put that value here, x and y, it has to be satisfied. Okay, so that's what we are discussing. Now, based on this constants, you'll get different other straight lines. You'll get another straight line if you change the constants. Okay, so if you write it as a0x plus b0y plus c0 equal to 0, that represents another straight line. If you write a1x plus b1y plus c1 equal to 0, that is another straight line. Okay, so this is what about straight line, basic thing. Now, if you look at this again, ax plus by plus c equal to 0. Okay, see this a, b, c are unknown now. In some cases, you will come across these a, b, c being unknowns. So here, if you look at, you have three unknowns. If you divide it with c, let's see what is going to happen. You will get a by cx plus b by cy plus 1 equal to 0. Now, this a by c, if you replace it with alpha x plus, this you replace it as beta y plus 1 equal to 0. Now you have only two unknowns. So sometimes you need to do this kind of conversions, and that is what we are going to discuss in the coming sessions. Okay, so I hope you understood. Now sometimes like this also we will do ax plus by plus c equal to 0. We will take that c to the other side and we will write it as minus c. Then you will divide with the minus c. Then this becomes a by minus c and b by minus c, etc. So we will do this also. Okay, I'll be talking about that to make this right hand side 1. Why? That's why you are dividing with minus c. Okay, then I'll say what is this and I'll say what is this. We'll discuss this more in detail. Okay, so that will be done in the coming sessions. That is slightly advanced. That has to be discussed in the next session after discussing the concepts of slope, etc. Okay, so let me now move on to the concept of slope of a line or gradient. Okay, so what is slope? Very important point that you need to understand. See, slope is, if you take a straight line, okay, in my Euclidean plane, if I take a straight line, this is your line L. If I ask you what is the slope, see, slope is actually the tangent of the angle that the line make with the positive x-axis. So then what is the angle that the line makes with the positive x-axis? This angle is what I am talking about. This is theta. So the line makes angle theta with the positive x-axis. So what is the slope? Slope is tan theta. Tan of the angle that the line makes with the positive x-axis is your slope. Okay, so I hope you understood this. So this is in case of acute angle. So what if it is like this? If line is like this, it will be the same again. So the theta will be like this. So slope here is tan theta 1. So if this is your L1, this is your slope M1. I will represent it as M1. This will be your slope M. Okay, so I'll represent this as M, that is the slope of this line, and the slope of this line I'll represent as M1, which is tan theta 1. So I hope you understood what is slope and what is theta. Theta is what? Theta is the angle that the line makes with the positive x-axis. So once you know that angle, you get the slope, tan theta. Okay, now let me talk of three different cases here, again, which is related to slope. See, in my xy plane, see, if I take a line parallel to x-axis. So this is a line which is parallel to x-axis. So can you see what is the angle that the line makes with positive x-axis? That is 0. There is no angle, there is no intersection. So here slope will be tan 0, which is equal to 0. Okay, so when it comes to line parallel to x-axis, since we defined our slope as tangent of the angle that the line makes with the positive x-axis, here there is no angle, so slope is 0. So line parallel to x-axis, slope is 0. Then what is line parallel to y-axis? Line parallel to y-axis automatically means line perpendicular to x-axis, right? This is the line. So line perpendicular to x-axis and line parallel to y-axis is the same. Similarly, see here, when I'm talking about line parallel to x-axis and line perpendicular to, see, this is perpendicular to y. So if you can get the question in this way also, line perpendicular to y-axis, slope is 0. Line parallel to x-axis, slope is 0. Now here I am talking about line parallel to y-axis. So when you consider this is parallel, but this is perpendicular to x-axis. So perpendicular means what is the angle that the line makes with the positive x-axis? That is 90 degree. So what is slope? Slope is tan 90, which is equal to infinity. So line parallel to y-axis, slope is infinity. Line parallel to x-axis, slope is 0. One more case is equally inclined angle. You will come across this also. See, what I mean by equally inclined angle is this. See, if you take this line which is passing through origin, which is equally inclined. See, any line which is passing through origin is not equally inclined. So this is also a line which is passing through origin, but that is not equally inclined. So what do you mean by equally inclined? This theta is 45 degree. So that is why equally inclined, because this side is also 45 degree. Okay, so equally inclined angle, or this is actually your y equal to x line. Why I am saying y equal to x? Because if y is 1, x will be 1. If y is 2, x will be 2. And very important line, guys, especially you will understand the importance of this concept y equal to x line when you move on to data interpretation. When I discuss data interpretation, I will tell you all these concepts. See, if on one side you talk of cost and on the other side you talk of expenditure, this y equal to x line means the cost and expenditure. Anything above will give you profit and anything below will give you loss. So just by looking into this line, the line will not be given. You can just draw the line on the given table or the information, and you can just look into, and you can tell that whether you are in a profit zone or a loss zone. Okay, that's the importance of this line. So the point which I need to tell you here is entirely different. I want to talk of the slope, right? If it is equally inclined, 45 degrees the angle, that means slope is tan 45, and tan 45 is equal to 1. Similarly, if you take this one, this is also equally inclined angle, right? If I draw like this is y equal to minus x line, y equal to minus x. Now this angle is 135 degree. Okay, so 135 degree. So what you need to find is tan of 135. Now we know this is in second quadrant. So 135 means either 90 plus 45 or 180 minus 45, and we know this is tan, and tan is negative in second quadrant. So you're actually finding minus tan 45. So slope is actually minus tan 45, which is equal to minus 1. So what is the slope of equally inclined angle? It's plus or minus 1 depending on the inclination. If it is 45 degree, it is plus 1. If it is 135 degree, it is minus 1. Okay, so I hope you understood. Slope of parallel line or parallel to x-axis is 0. Perpendicular to x-axis, perpendicular to y-axis is also 0. Parallel to y-axis and perpendicular to x-axis is infinity. And equally inclined angle, it is plus or minus 1 depending upon the inclination. If it is 45, 1. If it is 135, it is minus 1. Okay, so I hope you understood the concept of slope. Now I want to discuss one more important point, which is again related to slope, because see, if you take this line, okay, if you take this line, I give you 2 points on this line, okay, rather than giving you theta. Okay, so this is the angle that the line makes with the positive x-axis. So rather than giving that angle, we know tan of that angle is your slope. Okay, what I do is I'll give you 2 points. I give you this point and I give you this point. Okay, so, and I'll ask you to find slope, and slope is tan theta, but I'm not giving you theta. Now can you find it out? That is the question, right? See, let me take this point as P, x1, y1, and this point as Q, x2, y2. What you can do is drop the perpendicular, drop this perpendicular, complete this triangle, join this and mark this point as M. You can write this as S and T, not that relevant. So what is tan theta? Tan theta, now if you consider this triangle, in triangle QPM, see this angle is theta, so this angle will also be theta, because these two are parallel lines, and that will give you the same angle. So this has to be theta. So tan theta will be equal to opposite side. You can clearly see QM, that is opposite side, divided by adjacent side. Yeah, this is theta, so this is PM. Adjacent side is PM, right? This side is what I'm talking about. So opposite side QM divided by adjacent side PM will give you tan theta, and that is theta. Now, without knowing theta, we don't know theta. Can you find tan theta? That is slope. Okay, so tan theta is basically your M, which is your slope. If you can find it if you know this QM and PM. Now the objective is to get QM and PM. What is PM? PM is this length. That is nothing but this length ST. So QM equal to ST, no doubt in that. What is ST? See, this total is X2 and this much is X1. So this is going to be X2 minus X1. So QM, you are not QR, QM, that is PM, right? This is PM equal to ST. So that is nothing but X2 minus X1. What about QM? See, this much is Y2, this much is Y2, and this much is Y1. So QM is going to be Y2 minus Y1. Okay, now you got PM and QM, and now you can get the slope, right? Because your slope M is equal to, which is nothing but tan theta is equal to QM by PM. So you can substitute QM as Y2 minus Y1, PM as X2 minus X1. What you're getting is your slope. Okay, so now you are not using theta. Without using theta, if you know 2 points, you can get the slope. Okay, I hope you understood this. Now next is again very important topic, guys. See, if you have in my Euclidean plane, I'm taking 2 lines like this. Okay, so this topic is angle between lines. So I have my line L1, this is L1, and this is L2. So obviously L1 is having a slope of M1 and L2 is having a slope of M2. Okay, now obviously if it is m1, this has to be theta 1, right? And this has to be theta 2, because m2 is tan theta 2 and m1 is tan theta 1. So you can write that m1 is tan theta 1 and m2 equal to tan theta 2, right? So that is clear. Now, okay, what I need is, see, when two lines are intersecting like this, how many angles are formed? You can see two angles like this and two angles like this. But what if I tell you these two are equal? These two are in fact equal because they are vertically opposite angles. So if I mark it as theta, this also will be theta. Now if this is theta, this has to be pi minus theta. So this will also be pi minus theta. Okay. Now what I need to find is I need to get theta. Okay. So can you tell me theta 2? Theta 2, what will be theta 2 in terms of theta 1 and theta? See, theta 2 will be theta plus theta 1. You know that, right? Otherwise, you can think in this way. If you consider this triangle, this triangle, what is this angle? 180 minus theta 1 plus theta. And otherwise, when you consider theta 2, how will you get this? 180 minus theta 2. So theta 2 is equal to theta plus theta 1, right? So what I need now, we need a theta, right? We need to find theta. So what is theta? Theta will be theta 2 minus theta 1. Okay. Now, what is tan theta? Tan theta is equal to tan theta 2 minus theta 1 now. Now this is clearly of the form tan A minus B. So what is tan A minus B? Tan A minus tan B divided by 1 plus tan A tan B, right? So here it is going to be tan A, that is tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 tan theta 1. Okay, we know what is tan theta 2, what is tan theta 1. Just substitute tan theta 2 as m2 minus tan theta 1 as m1 divided by 1 plus m1 m2 will give you your tan theta. Okay, so this is your tan theta. So you can find theta by taking inverse. Okay, tan inverse of this will give you theta. Similarly, what if pi minus theta? We know clearly pi minus theta is in the second quadrant, and we know tan is negative in the second quadrant. So pi minus theta is going to give you minus tan theta. So that will be minus of m2 minus m1 divided by 1 plus m1 m2. Okay, so what is tan theta now? Tan theta is equal to plus or minus m2 minus m1 divided by 1 plus m1 m2. See, all this derivation is not required for you, but just that you will not forget it later. That's why I'm doing all these things. Okay, so otherwise you just need the final answer that I'm going to give you, reveal it to you soon. Okay, now what is theta? Theta equal to tan inverse of this thing. So you get theta. Now sometimes if you need to find the acute angle, if that is the acute angle, then tan theta equal to m2 minus m1 divided by 1 plus m1 m2 mod m2 minus m1 divided by 1 plus m1 m2. Once you got the acute angle, you get the obtuse angle. Okay, so that is the idea. So I hope you understood this. So theta is tan inverse of plus or minus m2 minus m1 divided by 1 plus m1 m2. Okay, now once you understood this, let's move on to a very, very important concept, that is condition of parallelism and perpendicularity. Okay, so first let's discuss about condition of parallelism. I'm taking in my Euclidean plane, I'm taking two lines. Okay, so this is my L1 and this is my L2. Obviously the slopes will be M1 and M2. So this theta, this is going to be theta 1 and this is going to be theta 2. Okay, now we need to understand this case. Okay, so parallel lines, we already understood that the angle between L1 and L2, right? See, the angle between L1 and L2 is 0 because they are parallel. Just before I have discussed this concept, right? So angle between L1 and L2 is 0. So when you take this tan 0 is going to be 0. Now let's apply the concept that we have discussed just now. What was tan theta? Tan theta was m2 minus m1 divided by 1 plus m1 m2, right? Just write that here, m2 minus m1 divided by 1 plus m1 m2. Okay, see why I'm saying angle between L1 and L2 is 0, because these are parallel lines, there is no intersection. Just now we have derived equation where you can see intersection, and we understood tan theta was m2 minus m1 divided by 1 plus m1 m2. So here the intersection is not there, so angle is 0, so tan 0 is 0, and we know this has to be 0. Tan 0 means you are getting like this, right? So m2 minus m1 divided by 1 plus m1 m2 is 0. It will become 0 only if the numerator is 0. That means m2 minus m1 equal to 0, which ultimately means m2 equal to m1. So what does this mean? If two lines are parallel, their slopes have to be and necessarily be equal. So this m1 and m2 must be equal, that I can write it as m and m. The slopes are equal, so obviously these angles will be equal. Why? Because if slope is equal, this is tan of that angle, this is also tan of that angle. Since these are equal, this angles will be equal. Okay, so I can draw any lines keeping this angle same. Either the angle same, automatically the slope m. Keeping the same slope, you're going to get the parallel lines. So the condition of parallel lines being slopes are equal. Two parallel lines, two slopes are equal. Okay, or you can say two lines are parallel if their slopes are equal. Second, we need to discuss the concept of perpendicularity. Okay, I'm taking two lines here. See, one line is like this and the other is like this. So I'm saying these two are perpendicular. So this angle is 90 degree. So obviously this is vertically opposite. This will be 90, this will be 90, and this will be 90. 180 minus 90. Okay, so this is these two are perpendicular. In which case it will be perpendicular. See, angle between them, we understood this is 90. Angle between them is 90. So we know tan 90 equal to infinity. We already know this, right? Angle between them is 90, tan 90 is infinity. So what is cot 90 then? See, tan 90 is infinity because of the denominator. So cot 90 will be 0 because the denominator is going to the top now. Okay, so cot 90 is going to be 0. Now what is tan theta? Tan theta we already know, m2 minus m1 divided by 1 plus m1 m2, right? So what will be cot 90? Will be the reciprocal. So 1 plus m1 m2 divided by m2 minus m1, right? Which is equal to 0. That means the numerator is 0. So that means 1 plus m1 m2 is 0. So m1 m2 will be equal to minus 1. And this is the condition, guys. See, what you understand? The product of the slope must be minus 1. So if two lines are perpendicular, the product of their slopes is minus 1. Okay, so two lines are parallel, the slopes will be equal. Two lines are perpendicular, the product of slopes is minus 1. Now from here also you can get it actually. See, tan 90 is infinity means when it will become infinity, the denominator is 0. So the denominator here is 1 plus m1 m2. You can equate that with 0 here also. Okay, but just to avoid the confusion, I wrote it as cot 90. Just to avoid the confusion. Otherwise directly also you can do this. Okay, so I hope you understood what all things we have discussed here. We went for the recap of what we have done till the third session. Then we started with straight line. I told you any first degree equation in x and y is a straight line, and the general equation we understood as ax plus by plus c equal to 0, being a, b, c are constants. Okay, you change these constants, you'll get another straight line. Okay, then we understood the slope. Okay, then we understood the slope of line parallel to x-axis. Then we understood the slope of a line parallel to y-axis. Okay, so one was 0, other was infinity. Then we understood the slope of equally inclined lines. We understood it as plus or minus 1 depending on the inclination. We understood the slope in terms of tan theta. We understood the slope in terms of 2 points. Okay, then we understood the angle between two lines. Based on that, we understood the condition of parallelism and perpendicularity. With that, we are completing this session, and we will discuss more of these kinds in the coming sessions. I'll be talking of a pair of straight lines. Then again, I'll be talking about circles, parabola, ellipse, hyperbola, rectangular hyperbola. Everything will be covered. So stay tuned. If you have any doubt, get back to me, this number. Okay, so see you guys.